Now let's have a look at some of the objectives for today's session, Lesson 1, Module 2. First, we'll start off with the System Development Lifecycle, also known as the SDLC, which we'll often refer to. We also then get into things such as the phases in the System Development Lifecycle to kind of discover or kind of figure out what it is that this entire cycle consists of and why it applies to software development specifically. Then we delve into legacy methodologies such as the waterfall methodology. Now this will be after we actually visit agile methodologies, which will be our priority for today's session. So let's get started by exploring what a software development lifecycle is. And essentially, the software development lifecycle is a key part of information technology practices when it comes to the enterprise world. The SDLC, also known as the software development lifecycle, has undergone many changes and evolved through the ages of big data, cloud computing delivery, artificial intelligence, machine learning, automation, for example. But it is still a key framework for delivering an end piece of software, either an application or full-blown system, to your end user or your client or your stakeholder. Now, the software development lifecycle comprises out of several characteristics that make it a software development lifecycle. There are so many out there, but for the most part, they kind of follow the same trend, if you will. Right? And generally, they comprise of several phases to delivering an end product, often a piece of software or an application or an entire system. And when we refer to phases, we refer to the beginning phase and the end phase, starting with gathering requirements from your client up until testing and modifying and so on. Now, a second characteristic is that there are so many out there, but the idea is that software development life cycles have grown and adapted since the use of modern technologies, for example, given the exchange in data and, the innovative technologies currently available. The idea is that as technology has grown, as projects have grown, so has the software development lifecycle to become more agile to account for these changes and needs. And then lastly, it's iterative and has incremental practices or steps, for example, which means there is a constant revision of one of the phases in the software development lifecycle. And when we say incremental, we ensure that when you're actually developing a piece of software, there always needs to be an improvement on that piece of software. And sometimes this requires an iterative approach. And let's have a look at a simple architecture of what a basic SDL architecture essentially looks like. We start off with requirements analysis, then we move on to design, implementation, testing, and then deploying and maintaining the software. Now, I'm showing you this early on because at a later stage, we're actually going to unpackage this architecture and get a feel for what each phase is all about in the whole life cycle. So keep that in mind for now because we will revisit this architecture later on to define it in detail. Now, we mentioned this thing called agile software development methodologies earlier, but let's take a deeper dive to explore exactly what it is. An agile software development methodologies is essentially an approach to software development using practices that allow software requirements to be gathered and solutions to evolve through collaboration within self-organization and cross-functional teams that often work in this thing called sprints or short cycles or short bursts. Right? And the idea behind this is to facilitate rapid innovation and the delivery of the final product or the software to the client or the stakeholder. Now, agile methodologies are very iterative and they require user stakeholder input. And this is extremely important. It's extremely important that users or stakeholders are involved in the process of the SDLC because it's their requirements that you're gathering. Therefore, when designing your system, you need to meet the expectations of how the software is supposed to function. And this includes non-functional as well as functional requirements. So when we refer to agile methodologies, we can think of it as an umbrella term because it houses many other methodologies out there. And these methodologies can either be used for software or for general projects or construction projects or whatever the case is. But there are certain characteristics about these methodologies that lend themselves to software specifically. And one of these include the Scrum methodology, for example. And Scrum is a framework for projects. And it's an agile methodology, like we mentioned before, which focuses on managing project teams and tasks through things like daily stand-up meetings, iteration planning, and short sprints within the life cycle of the project. And Scrum is quite important, or Scrum is quite popular because it offers an opportunity to ensure that there's an incremental improvement on every single delivery or every single task that some team member in the project team has to actually offer. Then there's also this thing called XP, or extreme programming, and this too is an agile software methodology, and it advocates practices that are focused on quality and software engineering techniques, and this includes the use of pair programming and unit testing. Now, there are some common characteristics between Scrum and XP, or extreme programming, and that is that you are trying to make sure there's an improvement with each iteration throughout the project's life cycle, or the system development life cycle. Right? And again, this is a lot like Scrum, not just for that reason, but also to ensure that you can go back and make slight changes. This is different from waterfall methodology, which we'll get to at a later stage. Now, XP, or extreme programming, also has a focus on the quality of life of the actual development team. So work isn't basically just everything. There's this focus on the development team, because the assumption is that if you can make sure your development team is happy, you can make sure the output that they're going to give towards the end of the project, or at the end of developing the software, is going to be of good quality as well. And then lastly, we have LSD, lean software development. And again, yes, this too is also an agile framework, and is based on optimizing development time and resources while eliminating waste and ultimately delivering what the product needs. Now, LSD is focused on delivering a MVP, or a minimal viable product to the market. And the reason for this is because you essentially want to get your software out as fast as possible, as lean as possible, with not all the functionality available, or the basic functionality at least, so that you can get feedback, take it back into the development process, and then refine it for further improvements. So LSD is more resource focused as opposed to actual deliverables and the development team and so on. Now, while we covered the project environment when it comes to software development, for example, as well as agile methodologies and these kind of things, there's also this thing called a feasibility study that all project environments take into consideration. And essentially, a feasibility study is a study that evaluates the resource constraints, the human labor, the time that it takes, all of these things that is required to go into a project at the end of the day, even cost, for example. Essentially, the idea is that a feasibility study tells you whether or not a project is viable or feasible or should be allowed. Okay, and here are some of the considerations that one must take into account. This includes a technical study, or technical feasibility study, an economical study, as well as an operational study. Now, let's drill down deeper and have a look at what each of these considerations actually mean, or how they carry some sort of value in terms of the project environment when it comes to software development. Technical feasibility essentially refers to a study of the function of the performance and the limitations that may impact the ability to develop a satisfactory system based on stakeholder expectations. Now, remember earlier we also said that when developing a system for a client or for an entire project, for an organization, it really doesn't matter what the case is, you would generally want to make sure that you meet your stakeholder expectations, because your stakeholder is going to determine what sort of functionality, which features, what your UI needs to look like, what your database needs to be implemented upon, and all of these things, even the flow of your data. Your client or your stakeholder is the starting point of everything, and your client will basically tell you, look, this is what I'm expecting an application, and this is how I want it to perform, technically speaking. Now, this doesn't necessarily just apply to clients. Even if you're developing your own sort of project or your own sort of application, your technical feasibilities that you must take into account. Can you meet the performance that's expected? Will the app or the software or the system function as it's supposed to? And what are the limitations imposed on actually delivering the system that you have in mind, or your client has in mind? And then we also have economic feasibility. Now, economic feasibility is an evaluation of the system development costs. And this is often weighed against the revenue or the profits or even the benefits that you'll yield as a result of developing the system. And this is quite important, because no single individual or no organization or no project is going to get kicked off on the assumption that, look, you just want to build something and there's no return on investment, if you will. Right? And we often refer to this as ROI. And ROI can be profit. It could mean so many things. But essentially, you need to weigh whether or not the system or the app or the software that you're developing will actually bring in some sort of benefit, whether it's tangible or if it's revenue or whatever the case is. And then lastly, we have operational feasibility. And this determines whether the work to be done will be operationally achieved based on your human labor or your human resources that you have available to you. And this is relative to time as well. Now, in the project environment, you'll often hear about these things called constraints. And some of the three biggest constraints include things like the cost, the human labor, and the time. Whichever way you go, or whichever two ways you go, you tend to sacrifice one or the other. And operational feasibility speaks to this in the sense that given your current resources and the amount of time you have to achieve the project, or the amount of time you have to develop the software, is it attainable? And essentially, this is what the feasibility study encompasses. It takes into consideration all of these constraints and all of these factors that's going to impact the quality and the end product of your software. So we've explored the SDLC in terms of defining it and some of its characteristics and why it's also important in software development. But now I think it's time to revisit the architecture of the SDLC we had earlier, just to describe each phase and what it's all about. Now, the first phase we generally go through is the requirements analysis, also known as requirements gathering or gathering requirements. And the idea behind this particular phase is that you gather all the requirements from the stakeholder or the client or even yourself if it's your personal project. And these requirements will form the basis of the scope of the project, as well as the functional parts of your software. Now, this includes non-functional requirements and functional requirements, what the website should do and how the website should perform, for example. And these are imperative because this forms the blueprint overall for what your design and your implementation will look like. Which brings us to our next point, design. Now, in this phase, developers start to design a high-level prototype of what the actual system is going to look like and how it's going to perform. And this is important because meeting those expectations early on from your stakeholder or your client is extremely important, because if they can get an idea of what the system is going to look like and how it's going to perform early on, they can actually give you feedback within the process. Now, keep in mind, this entire process is iterative, which means that each phase can happen more than once, and it's a cycle until the perfect acceptable system is actually deployed at the end. And then next we have the implementation phase. In this particular phase, this is where the coding starts as per the requirement of the client, the actual engineering and the software development by the team. So in this phase, everyone starts doing their work. Your database administrator starts designing the database, starts programming the database. Your programmers or your software engineers start coding the function of the website in a modular fashion, and they start piecing together the user interface and the actual deliverable of the system. And this is extremely important in this phase because once you hit implementation phase, it becomes a little hard to move back to design and requirements analysis, but you also have to be open to the idea that your stakeholder or the client is going to change their mind at a later stage. And this might mean that they want to see some additional functionality, which means you again go through requirements analysis and design, but you don't have to do so in a fashion where you have to start everything from scratch. That is really the case with SDLC or agile methodologies. And then once implementation has happened, the second last phase of the software development lifecycle, before the software is delivered to the client, in this phase we check to make sure that our system is working as per the expectation. And if it's not, we then have to sort of go back to the drawing board in a sense, but not entirely, and fix a couple of bugs or do a couple of hot fixes to the system and so on before we actually deploy the system. So stress testing is extremely important. Here we would maybe have a focus group and have them test the system, have them answer a survey based on their feedback and user satisfaction. What do they think of the user interface? Was the data flow really good? Here you start to test the application to make sure that expectations are met before you deploy to a bigger market, right? And then deploying and maintaining the application. Now, this is the last phase. It does not necessarily mean that the phase does not start over. Now, once software development is completed, we then deploy the software according to the client's user expectations, and this generally goes out to the entire market based on what the client's expectations were. If an issue is encountered in production, the development team is informed, and depending on how severe the issue is, if it's a severe bug or if it's something that can be fixed, the software has to either really take a step back and things need to be redone, or again, if it's a hot fix, for example, something that can be patched quickly, these kind of fixes are released in the next version of the software or the system. And then the system begins again with requirements analysis, depending on what features the client or what features you would like to see in your application, in your software at a later stage. And keep in mind, this entire cycle happens constantly. It's not to say that it comes to a definitive ending point. So I hope all of that makes sense when it comes to the SDLC and the actual phases involved. Let us proceed with our final topic for today, which is the waterfall methodology. And it's important to understand why we are covering the waterfall methodology, because this methodology was initially the first type of SDLC methodology. Now, let's define the methodology and then have a look at its architecture. Now, the waterfall methodology, or the waterfall model, also referred to as a linear sequential life cycle model, is essentially the earliest SDLC that was ever adopted, both in tech and in larger projects or various projects out there. And it was used a lot in software development, but it also had a lot of disadvantages and advantages associated with this methodology. And the advantages and disadvantages is something we'll explore at a later stage. The waterfall model illustrates the software development process in a linear sequential flow. And essentially this means that any phase in the development process begins only if the previous phase is complete. In the waterfall model, the phases never overlap and they are not necessarily iterative either. And when we take a step back and we just try to think about this for a second, what we mean by phases don't overlap and that one phase cannot start unless the other one is completed. Essentially, the waterfall methodology is restricted by the fact that you can't go back into your project and actually tweak things. And one of the biggest issues with this is that, and where it falls short compared to agile methodologies, is that it doesn't account for changes or uncertainty in the project, which is extremely important when it comes to any kind of project out there. Projects, whichever kind of nature they are from, they are always sort of surrounded by uncertainty because you never know what's going to happen. With external forces that play a role, these are things we must account for. And this is why the waterfall methodology was adapted to something more agile. And this is how we ended up with the agile SDLCs and methodologies. Now, let's have a look at the architecture, shall we? We'll notice that much, if not all of the phases are exactly the same to the agile methodology. And we have requirements, we have design, we have implementation, and then we have testing and deployment and maintenance as well. Now, this again is very similar to the agile methodologies like Scrum and so on and the SDLC. The difference here is that it has a sequential linear approach. Now, in the requirements analysis phase, it's not all that different. You still gather requirements from your client, but once you gather these requirements, they sort of set in stone, right? And once you start designing the system or prototyping the system based on the requirements from the client, you can't necessarily go back and make changes again. And then the same applies for implementation. This is where the coders come together, the database developers come together, they start putting everything together, the actual product that's going to be shipped or that they plan on shipping, the final product, and then this product gets tested. And I think in the testing phase, this is the only place where you have some sort of flexibility, but only to the point where you have to fix bugs. And then there's deployment and maintenance. Now again, you'll note that the flow here in this architecture is very different. You'll see we have these arrows which precede the next arrow or succeed the next arrow. And the issue with this is, again, to demonstrate the shortfall in the waterfall methodology. And that is essentially, once one phase is complete, there is no going back and trying to fix something that should have been fixed from the jump or from the get-go. Now, as we mentioned before, there are several advantages and disadvantages to the waterfall methodology. And let's take a brief minute or two to actually go through them. And this will give us an idea as to why we have agile methodologies and why we also stopped using them in the software development space. Now, the first reason is that it's less complex than agile methodologies, and this is considered an advantage. And when we say less complex, we're referring to the fact that because it lacks iteration and because phases don't necessarily overlap, for example, this makes it sort of easier, I would say, to draft your requirements in stone from the get-go, given that your client is very sure about the requirements moving forward. And this is extremely important to note, because if your client is 100% certain that they are not going to change anything, or that they don't have new expectations in the application later on, or the piece of software, or even the system, then it becomes a lot easier to actually develop the system, knowing what it is that you have in mind. Now, the second point is that prevention of uncertainty by validating and verifying requirements early on. And again, this goes back to the earlier point we made, that if a client is pretty much certain where they're going with their system, or what it is that they want out of the application, then the uncertainty, or the lack of uncertainty, or the prevention of uncertainty even, makes it easier to validate and verify that you're on the right track and that you're meeting the requirements from the get-go. Now, there are also disadvantages. The approach is linear early on and cannot be backtracked to previous phases, and this is something we iterated a couple of times. The fact that we have to deal with uncertainty in any sort of project makes it hard when a client eventually does come and say to us, look, you know what, I want to make a couple of changes in my system or my software solution. So you kind of have to go back and make those changes. And that means you have to go back to the drawing board, literally back to the first step or the first phase, draft the requirements again, do design from scratch, and then start implementation and all those things. Now you can imagine how long this process will take. So when adopting a methodology, it's important to make sure that the methodology that you're actually adopting is ideal for the project that you have in mind. Okay? And then lastly, less stakeholder involvement. Now this is also a drawback, because keep in mind, with agile methodologies, your stakeholders, your end users, the people that's actually going to be using your software or selling your software, these are the individuals that need to be involved in the process of the software development lifecycle. And this is imperative mostly for agile methodologies, because there is always uncertainty. Keep that in the back of your mind. And when uncertainty arises, you must be able to adapt very, very quickly. And this is where stakeholder involvement comes in, because the last thing you actually want at the end of the day is to build an entire system out, only to find out, you know what, your client is not satisfied, your client's unhappy, your client expected something different. And again, this is why user involvement or end user involvement is extremely important in software development. Now this brings us to the closing for the content for today's lesson. And as usual, what I'd like to do is sort of give you guys a challenge where I can, just to sort of spice things up a bit and to encourage you to do a bit of extra research. So for the challenge in this particular lesson, I want you to go out and identify additional agile methodologies that is particularly suitable for software development.